Hello and good evening. It's a pleasure to welcome all of you here with us. Let's get started tonight with our Technology Spotlight.
Remember how at the beginning of Star Wars, Leia's ship is getting tractor beamed into Darth Vader's big ship? If you ever stop and wonder, how in the world would that tractor beam really work, right? Well, let's look at one way that we might be able to do something like that. I want to show you what I brought with me, and maybe I'll show you and see if you can figure out how it works, okay? So this will actually levitate things, and I'm going to try levitating a little bit of water. So zoom in with me, and let's see if we can do this here. I'm going to make a little teeny drop right in the middle there. And there's a sweet spot, not right there. Oh, it's starting. There. There we go. So I'll bet you figured it out already. There's a little string right there holding it, right? No. This is actually levitating with sound. It's an acoustic levitator. Watch this. See if I can get one more in there. There we go. Okay, so this is a little bit hard to explain because it's so weird, but what's really happening here is there's an interference with the sound. So instead of sound moving through the air like it normally does with the waves, you know, the waves move across, there's a standing wave, which means there's an area where there's lower pressure, and then there's an area where there's higher pressure all of the time. So instead of moving back and forth, it's steady. I want to show you a little diagram here, if we can show it on the screen. There we go. This is showing where the areas of pressure are. And this standing wave stays constant like that the whole time. And so because of that constant pressure, it can actually hold things in that balance. You'll notice how, because of the special shape, there's an area right in the middle where it's stable, and it will just kind of float there. And the shape is what's really a neat thing about this. The guy who has been working on this in the UK first made a unit that had all these little transducers to make the sound, and he had them all hooked up to a big computer so he could adjust them all just right to do this. And it was really awesome, but it was quite expensive. But then he realized that you could do the same thing by spacing the transducers the right distance and tipping them the right direction. And so he came up with this shape, which a lot of people have been producing. I actually built this one myself and 3D printed it and everything. You know, I had to have one, right? But it's an amazing thing to look at, because how in the world would you levitate water like that, right? So let's think about what's going on here. These little teeny things you see in the picture are transducers. Not in the picture, but in real life, right? They're little transducers that make ultrasonic sound, which means that it's sound that you cannot hear, at least most people can. It's about twice as high frequency as most people can hear. So up like 40,000 hertz, 40,000 kHz, excuse me. And the top is making one frequency, and the bottom is making the same frequency slightly offset. And there's a little microcontroller down there that's keeping that offset just perfect, so the two waves hit each other in just the right way and make that standing wave we were talking about. And I have these little buttons up here. Let's see if we go back to a close-up of this, you can see if I push this and it's working. Let's see. There we go. See how they go up? And what's happening is the microcontroller is adjusting that frequency. Oh, I lost my cover there. And so it adjusts it just right so it pushes the water droplets up. And this one's supposed to do the opposite, kind of take them down. There we go. Oop, lost a drop because it got unstable. And then this last one is what I call bombs away. Just turns it off. There we go. Okay, so this is a really neat thing that you can do a lot with. here I got a setup where I have a whole bunch of transducers all pointed exactly right to make a stable environment where I can even levitate water. But you can do this even with just one transducer and a reflector. In fact, that used to be the way this was most commonly done. And the reflector could just be like a flat piece of metal or maybe the exact right concave shape. And if you get them the exact right distance apart, then the reflected sound waves off of the reflector come back and cancel with the waves that are shooting up from the transducer. So you can do this with just one transducer. Of course, it's not quite as stable as this, but you can still levitate a lot of different things. And the immediate question I had, well, can I make a levitating car, right? Let's go. But there are some issues. You notice how I could put the water droplets at different heights? Those were going in between the ultrasonic waves. These waves are about 0.34 inches long each. That's why the objects I'm levitating are so small. So if you were going to levitate something larger, you would need it to fit in that area. So you would need a larger wave, which would mean a lower frequency. So if you wanted it twice as big, then it would suddenly be right where some people could hear it. And if you wanted to do something quite a bit bigger, it'd have to be even lower, where everybody could hear it. And then if you wanted it to levitate something a little heavier, you'd need a lot more sound, wouldn't you? So it would be a pretty horrible thing to levitate something too large to listen to, at least, right? So this has areas where it might be really, really useful. For example, manipulating small things like fluid. If you have the original version with a computer that runs a whole bunch of transducers, you can actually move the water droplet around as you adjust the sound waves of all the different transducers. So that's pretty awesome. The guy who came up with this shape is now working on ideas of how you could use this to make 3D screens where you levitate particles that can make a screen that floats in midair and things like that. So the possibilities are endless of where this could go. But I want to talk about how you could use this for your science fair. You know, the science fair is coming right up in April, and so it's time to start getting your ideas and start trying things out, experimenting. And this is an idea that has a lot of potential for expanding, for coming up with new ways to use it. And so when you're coming up with your science fair idea, this would be a really awesome candidate. But if you do exactly the same thing I did, or the same thing that the guy who came up with this idea did, then you don't have as good a chance of winning as if you come up with something new and additional that you want to know about it. And then you have to actually create the experiment. You don't know if your idea is going to work. Then you have to create the experiment and try it and use the scientific method to see if you're on the right track. And that's how the real science gets done, isn't it? And that's when you go from a neat science fair project to a winning science fair project. So start thinking about that right now. And maybe yours won't be a levitator, or maybe it'll be even better. Maybe it'll be a levitator that can levitate big things. But always start with an idea of something that you think will really work. You know, I really thought I could make a levitator like in Star Wars, right? But there's a few problems. One of them is this is sound. There's no air out in space, so there's no sound. So Leia's getting away this time, I guess. So try to always start with something that you know works and how you can expand it or how you can use it to learn something new. And there are an endless number of possibilities. It's going to be really exciting. Well, that's all the tech we have the time for. Tune in next week if you want to see more.
All right, thank you, Dr. John. And please welcome Tobias for Breakthrough Moments in Science.
All right. Well, you know, we have moments where things don't make sense. Like tonight I stepped into the gas station, I was looking at the M&M stand, and they have the bulk bag, they have the medium bag, then they have these little bags, like the little ones, and it says fun size. Since when did small become fun? You know what? I'm just going to wear a shirt that says fun size. So, or, you know, you get those junk emails where it has a catchphrase to catch you onto the temptation of clicking and reading whatever it is. I got one that says, millions of people like you are making millions in their spare time. And I was just like, man, if I was making millions in my spare time, I'd go full time. So, but you know, sometimes things don't make sense. And, you know, as you're trying to discover new things or come up with ideas, as we expand our horizons of our understandings, we start breaking into things that were unknown, but now new knowledge empowers us. New knowledge empowers us to do things that we couldn't do before, that would seem like magic before. Well, tonight we are going to talk about someone named Philo Farnsworth, and as you can see, it ties to farming, but it doesn't. But before I talk about him and what he did, and I'm just going to break right to it. We're talking about something called television, okay? Now, before I talk about Philo, we do need to talk about one thing to help us appreciate some of what he did. And that was somebody had an idea in the early 1900s, even the late 1800s, when this radio invention came out. All these people started dreaming of ways they could use it. But some people, especially in Europe, started thinking, what else could we do? What else could we send through electric waves wirelessly and receive somewhere else? And some people wanted to try sending video. It wasn't called video at the time, but picture, moving picture, live sight through the electric waves. And so one of the ideas that was put forth was basically, I'm going to try to explain this really fast and hopefully it will make sense, but if you took a disc, like a cardboard disc, and he took a cardboard disc, this wasn't Philo, but this was someone in Europe, and he made a hole in it, okay? And then further in the disc, he made another hole, and another hole further in. And so there were these holes, and each hole was getting it was like a spiral of holes, and they're getting closer to the center, okay? So then he takes a light, a bright light, and puts it behind the disc, and then, okay, can you come stand here? Put someone over on the other side. They're probably like, what is going on? And they start spinning this disc. And what it's doing is the hole, first hole, if you're the lucky person sitting there, the first hole goes here, and it shines that light here. And then right after that hole goes past, the next hole shines the light right here. And so it's a hole, a hole. So it's doing these lines up your face, and then it does it again. And if he does it faster, spins it faster, then it does it faster, okay? Now he has these photosensitive sensors, basically we could call it, that are picking up that light that's getting zoomed across this face, and it's capturing the light brightness or lack thereof. And it's turning it into an electrical signal, which he then sent it and received somewhere else to another light that was flashing with what those sensors were picking up. And then he took another one of these circles with the same hole pattern and focused it onto a wall or a panel and put that other flickering light behind it and started spinning. And he had to spin it at the same speed as the other one. And the idea was that the holes would go up at the same time, and as the light was flashing to what these sensors were seeing, it would paint a picture in lines and kind of slow. If you think about it, you can kind of see it maybe on the wall or surface. And it was actually receiving that signal. That sounds pretty breaking, actually, pretty cool. This is some of what he produced. And that, if you think about what they accomplished with this, that's pretty cool. It was one of those where it kind of looks like somebody. That's what people say when I paint something. But this is actually one of the better ones. To get the people characteristics to shine through, they would even make their on-camera people, you know, on-camera makeup. Well, this was like a whole nother level. They would paint these black things like this, blue lips, and they needed features that make our brains distinct human face to shine through. So movie makeup had a whole nother connotation. But in fact, BBC started trying to do this, do live broadcasting with this for a little while. Can you imagine that? TV would be so different. Not to bash this, but it'd be like every show was a horror show. And it'd be like, and now for our weather report, here's Frankenstein. You know, but pretty amazing. But that's as far as it got. You had to have these two revolving things, and you know, obviously that's not going to work. Well, now we come back to Philo, and he's a 14-year-old boy in the early 1900s, and he's in Idaho, and his father farmed potatoes, and he found a book in the attic and got all these ideas, started learning about Thomas Edison and electricity, and some of the things that they were trying to do for this new, it wasn't called television at the time, but the idea. And so he thought electricity could be used to transform this industry, to make it an industry. And as he's kind of dreaming about this, he's plowing a field. And so he's got his horses, and he's doing a pass, and you know, that's how you plow a field. And then all of a sudden he stops and realizes, I know what we need to do this. Potatoes, no. He looks behind him, and he sees the lines in the field. And he realizes with an electron, electrons are as fast as light. So with an electron, I could scan lines of a picture fast enough that the human eye wouldn't be able to see. I mean, with this, we can kind of make it out if we let our mind blur for a second. There it is. Electrons, if I could find a way to scan electrons across in lines, then I could do something maybe. And so he starts working on this idea. And eventually what he comes up with is a way to be able to capture using a cathode tube. And he takes one and makes changes to it. And basically this is a glass, it's not a tube anymore, it's sealed. And it's got a vacuum pulled inside, so there's no air inside. And with the right setup and the vacuum, it basically allows you to send electrons like in a beam from one side to the other. And this is what he's going to use. And so to set this up, and I have a prop real quick. Yep, you know where this is from. So this is one of what would be in the camera, and this would be later actually from RCA, which we get into a little bit. But basically the idea was, so you take some kind of a lens and focus a picture, and there's a plate in here that's sensitive to light, and so it would focus whatever you're pointing at onto that. And then down here, it would shoot a beam of electrons. Now those electrons are just going to hit that and sit there, but we need to scan this whole thing. And so inside of here, he has electromagnets. And as the electrons flow inside of there, he uses the electromagnets to bend the beam. And so he takes the beam and bends it and starts scanning. And it starts just like plowing a field, basically, where it does one line, the next line, the next line. And it goes all the way down. It takes 30 lines, and then it does it again. And it's actually 30 with a space and then 30 more. So it's 60 lines. But it does 30 in 1 second. Now, as it does that, it sends out that electric signal, which is then sent as electric signal and then can be picked up by something that looks kind of similar to this, but it picks up that signal and has another similar setup where it's shooting electron beam, and it's shooting down in rows and reproducing that picture on another sensitive material. So that was the idea that he had, and he was working on it. He was 14 when he had the idea, and he went to his high school teacher and told him about it and actually drew it up on a paper for him, and he was really impressed that that might actually work. Well, kind of jumping ahead, RCA, who was kind of king of radio at the time, heard about this 19-year-old, he was 19 by then, and they sent one of their head people who had been working on this kind of a contraption but wasn't finding success, over to California where Philo had ended up working on this. And Philo gave him a tour and showed him what they were doing, and the guy even said, wow, I wish I had invented this. Well, we know that a telegram was sent to RCA in New York, and by the time he returned, they had a working setup. So, but eventually they tried to make an offer to him, basically saying, hey, we'll give you $100,000 for you, your product, and your company. And he said, well, no, I'd rather do it in a royalty setup because I really want to be able to control it. And they didn't like that, so first they looked at getting around his invention. They couldn't, so they just used it and decided they were so big. And anyway, in a lot of court cases, and basically their argument was, how could a 14-year, seriously, we're fighting over whether a 14-year-old boy came up with this? Could that really happen? That's not happening. Pretty strong argument, I guess. And he was trying to find something to prove that he did this, and then his high school teacher came forth and said, I have a paper that was drawn, and he showed it, and they were able to prove it, and he actually won. But in the long run, RCA still held on to most of the money and the credit for it. But amazingly, this was invented before movie cameras. I mean, we weren't, when they got this working, there wasn't a way to save the video. They could send it and receive it, but recording shows, that just didn't happen at the time. So pretty amazing that this happened that long ago. So, you know, you never know when an invention idea is going to come, whether it's plowing a field or meeting someone and seeing their good idea. But, you know, it really comes down to, you know, how big, do you have limitations or not? And sometimes there's brand new discoveries that are going to let you go farther than anyone's gone before. So, and just real quick, here's a picture of him, and here's a picture of the first large one that he got working. So this is the receiving end that's putting it out. So that's the inside of a TV screen. There would be a square frame that would be put around it, but that's it being shown. So, and that's the breakthrough moment for this week. Thank you.
All right, thank you, Tobias. And now introducing Dr. Paige Monet.
For everybody wondering if this is
Can you
live.
guys hear her microphone?
Really?
I guess you have to. Hello?
Hi. Yeah, for everybody wondering if this is a live feed, it is. And I'm going to do my thing. I get to introduce.
Whoa.
This is the fire part of Angel
This
tonight.
is her thing.
This is my thing. I get to introduce a very interesting person. And see, that silence there lets all your mind start filling in. You have the ability and you have a treat. And that is to hear from Dr. Billings tonight. We hear from him every week, and we think that it will happen every week. Wonder, ponder, what if? And then tonight, I hope that it piques your interest and it makes it so you listen with different ears, because things are not always known and moments that come after aren't always seen. And this is the most exciting time to be alive. So, Dr. Billings. Didn't see that coming, did you?
Did you finish doing your thing?
Just 1 minute.
Sometimes I think about her kind of like Princess Leia.
Help me,
So
Obi-Wan
this is
Kenobi.
Princess Leia, and I am Darth Vader. You
No,
know,
Obi-Wan,
Dr.
I
John
like
really inspired me tonight. Levitation. If you can figure out a way to levitate big things, he said, then you can catch or capture Princess Leia.
I'm a big thing.
While he was saying that, my mind went into high gear.
Did you figure it out?
I did. I invented how to levitate big things. It's an amazing invention, and I just made it tonight while he was up here inspiring us. It's such a good invention, I started off right away. You know, I thought, this invention needs a name. What shall I call it? Mozzarella? Oh, that's taken. And then I thought, you know, just a simple name. So, guess what I named it?
I don't know. I'd love
I
to.
named my invention Jack.
Jack?
Mm-hmm.
Jack?
Yeah, you use it at a gas station too. You put it under the car and you levitate it. What do you think?
Those are really nice.
Okay, well, anyway, it was really good. I enjoyed it very much. And thank you for sharing with this invention of television. You know, plowing a field, that became his discovery moment. But the only reason that it could become a discovery moment is because he was thinking about being able to send an image over radio waves. And one of the things that I would hope tonight, and I did not have this rehearsed with her, but one of the things that I would hope out of these discussions is that something may trigger your mind to an original idea. And it's not an idea that I have that I'm trying to transmit to you. It's an idea that is original with you. I like the fact that John's got us thinking about the science fair. And I remember in my own experience how much I benefited from the science fair program. My hydrogen car project took 3 years to complete. 2 years I couldn't get it going. Third year I did, just before I graduated. But the science fair was the motivation I needed to work on it. And it has really changed my life, and now there's a lot of hydrogen cars zooming around, and I think there'll be a lot more in the future. So thinking about the science fair, and you know, whether you're in school and the science fair is an option, or if you've already graduated, there still are your things, the things for you to see and to envision and to figure out. Conceiving an idea is the first step. And then having the faith and confidence in yourself to be able to do something about it is the next step. So I want to talk a little bit about technology tonight. And I'd like to kind of talk about something a little bit, well, it's an October subject, you know, it's a little bit spooky. Spooky, you know, Einstein observed something about quantum physics, and he called it spooky movement over a distance because it was unusual, it was a little bit different, and we didn't understand it. Einstein kind of decided that that's not real. It's a faulty experiment. And years later, as we developed better technology and experience, we found out that it was. And there's still some really amazing things being discovered about that. So some of the things that might be a little controversial today could become a reality tomorrow. And I think that's pretty neat. I saw in the news that they were reporting that 900,000 people in California might have their power turned off because of a shortage of rain. So the reservoirs are low, they cannot run the hydroelectric generators, so they cannot generate power. I didn't study in detail, I just saw that headline. But think about that, 900,000, that's a lot of people. And what would it be like, you know, surfing the internet without electricity? Pretty soon your battery dies, then you're in real trouble. Tonight at dinner, one of our students was telling me about how he is right now working on a suit that would charge the computer back up, and that'll be a good thing. But energy is a very, very important part of our everyday lives. And in our world today, it's even become something of a matter of life and death. Used to be that we would farm by hand or use beasts of burden, plow horses or oxen to be able to plow up our field and to cultivate it. But today, that technology is largely lost. I have a little ranch where I like being what my neighbors call a play farmer. And I said, what's a play farmer? And they said, it's someone that pretends they're farming just for fun. Well, that's not so bad then. But you know, I have horses and dogs. And in this little farm, I have some neighbors not far away that are part of an Amish community. And their program is they don't have any electricity in their community, and they do it because they think it's important to be able to live without electricity. And so when I get ready to plant, I get on the tractor, or I get one of you to get on the tractor. And that tractor, you know, the wheels are bigger than I am. And boy, it can do, how many feet wide can we do plowing? 30 feet wide. It's really helps get a big field done. And we use a lot of energy, which in the case of our tractor comes from diesel fuel. Diesel fuel comes from petroleum, which comes from sunshine falling on the earth a long, long time ago, storing it up for us. My friends down the road a little ways, they don't have tractors, they have horses. And it really is neat to watch them going through their field with their horse pulling the plow, and they're there guiding them, and it's quite an art form. I realized that if I had to get one of my horses to plow my field, I would truly go hungry. first of all, my horses aren't accustomed to that kind of work. They're a little bit pampered and spoiled. And the other thing is I don't know how to do that. And it would take a lot of time for the field the size that I try to plant. We are able to produce a lot of food in this country because we use mechanized equipment, like tractors, like combines to cultivate, etc. And if we didn't have those, we couldn't produce that food. So a lot of people are really concerned about global warming. They're concerned that because we have burned fuels and we're continuing to burn hydrocarbon fuels, that we're building up greenhouse gases in the atmosphere, and it's making the earth hold the heat, and therefore the weather is changing, and it's melting the polar ice caps, and the ocean's going to go up and eat some of our lower lying cities, and there's a real fear of that. And yes, the environment is extremely important. And so some are saying we shouldn't burn hydrocarbon fuels. It turns out that the state of California has been against burning hydrocarbon fuels for quite some time. If they would burn natural gas in California, I don't think they would have problem producing enough power for these people during a drought. But they're so concerned about the environmental impact of burning natural gas that there's been a lot of resistance. And so now they're caught with this drier weather, and they're not going to be able to produce the power. Well, how bad could that get? And how do you balance that off? And what about global warming? And there's a lot of questions there that a lot of people have opinions on, including scientists and including non-scientists. And I don't want to go in on that debate, but what I do want to go in on is even more controversial, and that is, what if we could get ZeroPoint energy? What if we could get energy from nowhere? And if you guys want to make a really good science fair project, this would be a great one. If you need one to help you with marketing it, just think, what if you could make a little black box, about that big, and you could use it to just generate power? We could take those to all of those 900,000 people and say, hey, your lights are out. Would you like a power box? They say, sure. What kind of fuel does it? Oh, it doesn't need fuel. Just sit it, under the table in the kitchen and hook it up, and your house will be lit up for the next 1,000,000 years. Sounds a little far-fetched, doesn't it? Well, years and years and years ago, one of the mentors of my mentor was very much into energy. His name was Thomas Edison. Remember him? And I learned from Bill Lear that Edison mentored Lear when he was starting out and designing radio circuits. And so I've been very interested in Mr. Edison. He's a great, prolific inventor. I think he still holds the record of the most patents of anybody that has ever lived. It's interesting, one of our Celis teachers, of course yet to be released, David Hall, is, excuse me, is starting to approach that number. Hydrogen water. Yeah, this is the old-fashioned kind.
They want to know if you actually really invented the car, Jack.
I invented it mentally. No, just tonight. I invented that would levitate something very heavy.
There you go.
Yeah, I'm not sure if it would catch Princess Leia, but maybe if we put my invention of a jack, which of course I go down to the store and buy, and put it under your white car and jack it up, when you were going to drive away fast, the tires would just spin.
That would be kind of cruel.
That'd be a capture.
That would be a capture.
So ZeroPoint Energy we were talking about. And Mr. Edison invented the light bulb, and now everybody wanted electricity so they could have electric lights and other things. Radios were coming out, etc. So they started making electricity generators. It turned out that New York City, which was a real hub of population, wanted to get a lot of electricity to offer it to a lot of their residents. And people started noticing that not too far away was Niagara Falls. Niagara Falls is this great big river that all of a sudden fell over a cliff and fell a long, long distance. And they thought, man, that's a lot of energy. If we could turn that into electricity, we would be able to light New York City. And it turned out that the technology of running it through a water turbine, it's like a pinwheel, and making the water turn the wheel, which then ran a generator, that technology was available. But the problem was it was too far from New York City. And by the time, if you build a power line to go from Niagara Falls to New York City, by the time it got there, the power would be used up, just bringing it to the city. And that was the time that another inventor came on the horizon, Mr. Tesla. Tesla came to this country as an immigrant. He had done some interesting work overseas before he came. He had a very interesting background and an extremely clever, sharp mind. And he was all excited about the idea of using alternating current as compared to direct current. And we all need to remember what those are. Direct current is the kind of power that comes out of a battery. If you turn on a flashlight, you're running the light with direct current. That means you turn on the battery and there's a positive and negative terminal. It actually turns out that the electricity flows from the negative terminal through the light to the positive, and it just runs constant. That's direct current. That's pretty simple. But this thing that Tesla was excited about is alternating current. And what is that? Well, that means that it alternates. It means the electricity flows this way, and then that way, and this way, and that way, and this way, and it changes directions, in this country at least, 60 times a second. Over in Europe and half of Japan, it changes direction 50 times a second, 50 hertz, 60 hertz, okay? Well, why in the world would anyone want to make the electricity dance back and forth like that? Seems like kind of a crazy idea. And Edison really thought it was a crazy idea. He really opposed it. And eventually Tesla left and he went over and started doing his own thing, got involved with Westinghouse, a lot of interesting stories. But the bottom line was he came up with an alternative approach to bring the power from Niagara with alternating current. Why? Why do alternating current? That's what I think Edison used to say. Why? Why do alternating current? And the answer was real simple. If you have a current going one direction, and by the way, think of alternating current like you have a flashlight and a light bulb, and you've got a battery, like maybe a 9-volt battery, and you put it on and the light comes on, you pull it off, you turn the battery around and put it on, the electricity goes the other direction. And you keep switching the battery 60 times a second and you have alternating current. That's all it is. You just keep switching directions very fast. You can do that with a generator so that it goes very fast and there can be a lot of power. But here's the amazing thing. When you put alternating current in a coil of wire, it creates a magnetic field for a 60th of a second, and then it has to flip the magnetic field around backwards because it's running the other direction. And almost as if by magic, if you make one coil hooked up to alternating current, and you put another coil on top of it, but they're not touching, especially with a metal core, the electricity jumps from one coil to the other. So you put it in here and it comes out there. And we call that a transformer. But then comes the real magic. Let's say on this bottom coil you're putting the energy into, let's say it has 100 windings. You coiled it 100 times around a core, and it's making an electromagnetic field 60 times a second because the power is changing direction. But then on the top one, instead of 100 windings, let's wind it 1,000 times. What would happen then? Well, the voltage would still jump from the bottom coil to the top one, but it would come out of the top one at 100 times more voltage, 100 times 10. So if you put it in the bottom at 100, it'd come out the top one at 1,000. It will step the voltage up and it'll step the voltage down as a ratio of the number of windings of the two coils. So if you put 100 on the bottom one and you put 10,000 on the top one, then it's going to go way up. And literally, that makes it possible, because of the very, very high voltage, it makes it possible to send power very long distances without losing all the power on the way. Because you got such a high voltage, it pushes so hard that the resistance is greatly reduced, the resistive loss, the voltage drop as we call it. If you see those big girls with wires, that's what some of the power lines look like to me. They look like girls out there holding wires. Could be girls with wires. But anyway, if you see them, those high tension power lines might be 1,000,000 volts. They've stepped the voltage up that high, and they did it with transformers. That was what Tesla wanted to do. With Edison's idea, transformers don't work. When you run direct current into a winding, it doesn't jump to the other coil. Because of the high voltage of these transformers, it was possible to bring power from Niagara Falls, and then a lot of things happened. So there is a little story about power, but with alternating current or direct current, you still have to get it somewhere. And you got to get it from a waterfall. You got to get it by burning natural gas, coal. You could have a nuclear reactor where a reaction's taking place and it's making power that way. Interestingly, our friends over in France get a majority of their electricity from nuclear power. In this country, we don't, because, well, it seemed like we were starting to really get fired up to do it until we had the accident at 3 Mile Island. Then we stopped building nuclear power plants. You could get it from solar when the sun's shining. Solar doesn't work as good at night. But also solar is still pretty expensive. To be able to generate all the power we need from solar would really cost a lot. And though it's getting more and more popular, and I think the real problem with solar is we haven't figured out a really affordable, efficient way to store the power for night. So you've got all these issues. Well, what if we could just come up with a black box that would pull power from somewhere that maybe science doesn't even understand today? And that was something that Tesla seemed to really believe in. He believed that there was power out there that we could tap and bring in for our use. He also proposed that you could put power into the cosmos, well, I'll say in the atmosphere, and pull it out other places on the earth. And he built experiments to attempt to do that. There was a guy that I think was a friend of Farnsworth that we learned about today, and his name was Moray. And this is a real interesting guy. I have made it a personal project to read everything I could find about Dr. Moray and the research he did. But he invented a thing he called a Moray tube. And this tube was supposed to pull energy out from wherever. And he built some pretty remarkable prototypes. And I want to tell you a little bit about him, a little bit about the story, because I think it's very fascinating. So where could that energy come from? Now, we pretty well know everything there is to know, don't we? And I remember they said back at the start of the 1900s, they were thinking about closing the patent office because everything had been invented. Of course, that was before Apple. You know, it is amazing how much we always have to learn. No matter how much we learn, there's always, it opens vistas of more opportunity. But before Einstein and the other scientists of his time, it was just inconceivable to think that you could just take a little chunk of rock and turn it into huge amounts of power like we use in our aircraft carriers. Our aircraft carriers, which are floating cities, 5,000 people live on these cities. They're huge, they have a runway, and they float around on the high seas at pretty high speeds, all powered by nuclear energy. And nuclear energy is really easy to understand if you think about it. There's two kinds, fusion and fission. In the nuclear carriers, we use fission. In fission, you take a material that's radioactive. What does that mean? Well, can you pretend this is a Geiger counter? Mm-hmm. Okay, a Geiger counter is, if it gets a radioactive particle, it makes a click, click, click. If you have a Geiger counter and just have it here in a room, click, click, there'll be a few clicks. But if you go out in Nevada, for example, where there are big reserves of uranium, and start going around there, click, 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 and start getting a lot of radioactivity, you have just discovered uranium. Uranium is a big, heavy atom that is radioactive. And what does that mean? It means it listens to the radio 24 hours a day.
Love it.
Very active. Actually, what it means is this atom is unstable. And every once in a while, one of the atoms in a chunk of uranium breaks into pieces. It just kind of blows up, and it gives off energy particles. And what we're picking up at the Geiger counter, some of those energy particles. Why doesn't it just blow up? Because the uranium atoms are spread so far apart that there's not enough energy concentrated to do much. But here's the interesting thing. If you take one of these atoms that is waiting to blow up, and a particle from another explosion comes over and hits it, then this will blow up, give off multiple particles. And if it hits another uranium atom, they will explode and give off particles. So what do you have to do to get a chain reaction going? You have to dig up the uranium ore, and you have to purify it. So you have one atom here, one atom there, and the rest is all dirt. But when you purify it, then all you have is uranium atoms. And if you get pure uranium atoms all together, then you get a chain reaction. And one little atom that explodes will trigger 2 more, will trigger 4 more, will trigger 8 more, and it gets hotter and hotter and hotter. Unless you cool it, it'll melt down or explode. Okay? So in a nuclear reactor, they create fuel rods that have this fuel, which means uranium, and they put them in a reactor underwater to keep it cool, and they have control rods, which are just rods of the metal, usually lead, that absorb these particles. And if the control rods are stuck down in the reactor, then the particles that are coming out are absorbed by the lead, and it's cool. But if you want to turn it on, if you want to get some electricity out of nuclear power, you just pull up the lead rods. As you start pulling it up, they start getting more chain reactions, and the temperature starts going up, and the water starts getting really hot. And you run that water through a turbine, just like it was a waterfall. And that's how you make electricity from nuclear power. And if you're starting to get too much power, you push the control rods down, and it slows it down. And that's what they do in a aircraft carrier, is they have a reactor like that with control rods to keep it going at just the right level for how much power they need. If they get into a difficult situation and they've got to move very, very fast over the sea, they just pull the control rods out, and this thing starts getting extremely hot. Well, after a while, all of the uranium is going to be used up, and they've got to put new fuel in. How long do you think that takes for an aircraft carrier? How long before all the fuel's used up and it doesn't have enough reactivity to really power the ship? What do you think?
I don't really know.
2 months.
2 months.
1 week. What do you think? A day?
Oh, I thought you were telling me.
No, I'm asking.
I want to know. I don't know. Like, you have your own.
I don't know either. Does anybody know? Go ahead. Scott. 10 years. 10 years. I hear 10 years, I hear 15. 15 going once. And I hear 10 to 20 years, depending on the reactor, et cetera. Imagine 10 years, even 20 years, with the fuel just running, generating power. Now, if someone had said that before the period of Einstein and the early nuclear physicists, we would politely laughed at their stupidity, but we don't now, because we see those nuclear-powered vessels going. When I was in my sophomore year of high school, I won not the science fair with the hydrogen car, that was going to come 2 years later, but I won a prize called the Navy Science Cruise. And that meant I got to get on a Navy propeller plane and fly to California and go visit these installations with the other science fair winners from around the country. Well, it was a neat thing, wonderful experience. That was my military career. We spent about 15 minutes in boot camp, which is just right. You know, boot camp's where you kind of learn to be tough. Well, we walked through there. I figured, boy, it's enough boot camp for me. But one of the highlights of my experience is they took us into a nuclear-powered submarine. This is a submarine that had one of these nuclear reactors, and this was a missile-carrying submarine. In fact, the one that I actually went into was called the USS Daniel Boone, which was close to my heart because I am actually the descendant of the cousin of Davy Crockett. And so it makes Daniel Boone kind of like family to me. Anyway, the Davy Crockett thing's actually true, but and I was not born on a mountaintop. But at any rate, in the USS Daniel Boone, you have this little submarine, and then when you go down underneath, it gets bigger under the water, and it was huge. It was a big thing, and this thing was powered just by rocks giving off radioactivity. And of course, we had a lot of questions, us little science guys, and we were down there in the control room, and one of the guys says, so how fast can this thing go? I remember this a few years ago. But he said, well, I can't tell you. That's classified. He says, but I will tell you, when we shoot a torpedo, we can outrun it. Wow, that sounded pretty fast to me. I don't know how fast torpedoes go, but that sounded pretty good. Well, my point is, it seemed impossible to believe that someone could come up with, you go get those rocks out of that mountain out there in the desert, and you clean out the sand and the dirt and make it more pure, and all of a sudden you can generate enough power to run a city, to run an aircraft carrier or a submarine. And a lot of our biggest space projects, space satellites, run off nuclear power. That's exciting. I mean, and no one saw it coming. Well, what other things are there out there that we can tap into on energy? And a lot of people think there is a zero-point energy source. There's a way that you can just have a black box and it pulls energy from nowhere. Since I got a little notoriety in the science fair for the hydrogen car, I have become ground zero for the inventors of zero-point energy devices. I've had a lot of them come to me because I guess I'm supposed to know all about it. And some of them are really wild stories. Now remember, I got to get back to Dr. Murray, but I do want to share just one or two of these stories because they're really good stories. Am I off path?
No, this is your thing.
Okay.
I did my thing.
Okay, I'm going to take just a minute out for a paid commercial announcement from Princess Leia.
Help me.
Did you see that look in her eye? She looked at me like, you're supposed to be inspiring these kids, and you're talking about ZeroPoint Energy. Parents are going to write in and say, what is he doing?
I've never heard you're ground zero for these people. That's perfect terminology.
Okay, well, just let me, this is for her. Ladies and gentlemen, students of Acellus, future of America and the world, I want to remind you that so much of your success, how am I doing, is dependent on attitude. It's about attitude.
You're doing good.
So there was a young man that worked for a shoe company in New Jersey, and they were looking for a new market for shoes. So they sent this young man down to the jungles to sell shoes. And he got down to the jungle all excited about the shoes he would sell, and he found out nobody wears shoes. So he wrote back a letter, I'm sorry, I got bad news. No one wears shoes down here. This is not the place to come. So he went home. But one of our very, very brilliant Acellus students got sent down from the competing company, and he went down there, and he saw all the people barefoot, and he wrote back to his company, good news, nobody down here has shoes. We're going to sell a ton of them.
That's good.
Okay?
That's good attitude.
Positive attitude. Not going to go back to my story?
Yes.
Okay, thanks. So like I was saying, ZeroPoint Energy. One day I got a call, and I got to be careful how many of these names I can use. So I'll just say one of the really big car rental company presidents called me, and he identified himself. I am the president of bleep, 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 rental company. And boy, I knew that name because I rent cars. And he said, I need to have you do some consulting for us. And he asked me if I would fly to the city of their headquarters because they had an amazing new invention, and it was a black box into which you poured water, and it would give out enough hydrogen to run a bus, car, whatever you wanted. Unlimited fuel. As long as you have water, you have fuel. I said, well, yeah, I thought that was wacky. I said, I don't know. And he said, I'll pay you well, and we're putting a lot of money into this, and I just want a second opinion from the inventor that's working for us. And so I agreed to do it. But before I left, I went into our chemistry laboratory, and I got some metal ion papers. These are papers that can tell if you have an ion of certain metals like sodium, magnesium. There's a bunch of them. There are some metals that if you put them in water, they react and give off hydrogen. And I thought, wonder if there's anything like that going on. Well, I got down there, and they made me leave everything, and we go into the secret room, and here's this little inventor and the son of the president of the company. And of course, the president, take me in there, and here's the little black box. And he turned it on, and a gas started coming out of a little tube. And remember, I told some of you about hydrogen. First thing I did is I listened to the gas, put my ear out, which is kind of scary when you think about it, but I put it out like that so that the gas went in my ear, because hydrogen atoms are so small that if you breathe hydrogen and then talk, you sound like Minnie Mouse, right? And in your ear, you have these little hairs that vibrate depending on the frequency of the sound. And if you have air around, it sounds normal. If you have hydrogen in your ear, I found out one day, it makes it sound, everything sound like Mickey Mouse. So I just took a little whiff of it in the ear, and then I could hear everything strange, so I knew that's hydrogen. That's my hydrogen detector. Now, there's better ways to detect hydrogen than that. This is way back, you know. So I knew it was hydrogen. It was coming out, and then they lit a flame, and it burned this nice big flame, and it was just water. And he said it can run on water, tap water, pond water. It can run on Coca-Cola. I was blown away. Just think, what if you just get one of those boxes in your car, you never buy fuel again? Try buy the gas. The only reason you stop at the gas station is to get Coke. You know, put in your car. Yeah. Well, ladies and gentlemen, that would be really exciting. And So I said, I want to get something. I went back out. I got my little bottles of these test papers, and I came back in and I pulled one open, and I'm going to pull it out. And the inventor said, "What are you doing?" "No, I'm just going to test the gas." And he went violent, and he chased me out of there. And when we got outside, he says, the guy that invited me to come said, "What did you do to make him so upset?" And I said, "I don't know. I was just going to test his gas." And then I asked the guy, "You don't have to answer me, but I'm going to ask you a question. At least you can think about it." And I says, "Is it possible that you got this wonderful invention, but there's just one little problem you're still solving, and that is the catalyst is used up, it corrodes?" He said, "How'd you know?" And I says, "Because if I was going to make a black box like this, I would put a metal in there, and it'd be one of about 5 or 6 metals, that whenever you put water with it, it corrodes and gives off hydrogen, but the metal costs 10 times more than hydrogen does, and you're going to be out pretty soon." And I'm pretty sure that's what it was. But here's this guy, and he was trying to sell this invention for $1 million. It was just corrosion. Now, I don't appreciate scientists that kind of fudge when they know that what they're doing is not right. And I think this guy might have known, and that's why he didn't want me testing. But there was another guy. I got a call from one of my physics professors at the university. And he says, "Roger, I've just seen something you've got to see. What is it?" "It's in South Carolina, and it's a motor that runs on ZeroPoint Energy." To me, ZeroPoint Energy is energy that comes from we don't know where. And I said, "Well, I don't know if I believe in things like that." He said, "You got to come and see it." So I did. I went clear there, and I go in this room, and there was a piece of plywood sitting on a table. And on top of the plywood was this other piece of plywood that was cut in a big circle and had a bearing underneath it so it could spin. And then he had these S-shaped magnets glued on the top piece of plywood in these weird shapes. Now, an S-shaped magnet is just a magnet kind of shaped like that. And he handed me a magnet like that, and he says, "Okay, this is the switch. Put it down by the wheel." So I put it down by the wheel, and this thing started turning. Pulled away, and it stopped. Turn, stop. I lifted up the board. There were no wires. There were no hidden compartments. And I was so amazed because this thing was really working, and I couldn't see how it could possibly be so. I thought, well, maybe there's something in this room. Maybe there's something funny going on. And the guy said he'd bring it to my lab. And he did. And we set it up in my lab, and I did it, and it still worked on my bench. And I'm starting to really get curious. So then I wondered, could it run overnight? So I got a clamp called a ring stand with a clamp and hooked the key on that and put it right down where it was supposed to be, and it started to turn and it stopped. And every time I'd move the key in with this clamp, it wouldn't work, but when I'd hold it in my hand, it would. And then I found out that as the thing turned around, the magnets would pull at each other, and as it would try and make my hand turn, I'd fight it. It was powered by my muscle. And I don't think this inventor knew what was powering it. I asked him how it worked. He said, "I don't have any idea." I said, "Well, how did you know to build it?" And he said, "Well, this is like the 200th try." But how clever is that? Well, so I'm saying there's a lot of strange things out there, and you got to be a little careful, because if it's too good to be true, it probably is, right? But then there's this Dr. Moray, and there's something that he did. He made a thing that he called a Moray valve, and it was a little black box, and then he hooked it up to a whole array of lights, 2,000 watts. That's quite a bit of power. He turned it on, and it ran, and it ran, and it ran, and it ran. Now, I never met him, but, and he's passed away now, but a lot of people that I highly respect, and some that I know, did meet him. It was very, very fascinating. There were 3 great scientists from the university that I attended in the science and engineering department that did an experiment with him, and they tested this thing, and they thought, where is this power coming from? And so then they loaded in their car and they took it way out in the country, way out, away from power lines, away from cities, away from radio stations, away from everything. And they said they picked where they would stop. And he did not know in advance. He set up the equipment, and on came all these lights, and they ran for 24 hours. Now that one to me has credible scientists backing it up, and it has a pretty credible story. I don't understand how it works. He felt like he wanted to keep some of his ideas private, secret, but it appears that it did work. ZeroPoint energy is something that could really change our world.
So I'm supposed to talk? Okay. I'm supposed to talk science. That's not my thing. Mine's ESP. Different kind of science.
For a minute, she had control of my brain.
I sure did.
It was awful.
Was it that bad? Really?
Yeah. Anyway. But here's my point. ZeroPoint energy. Is there a way to pull energy out of the universe somehow? Well, there wasn't pulling it out of rocks. Nuclear fusion, which is hydrogen atoms fusing together to make helium, that's the way that all the stars are powered, including our sun. And all of the energy that we see coming in from the heavens is generated by that process. We have a lot of hydrogen, and even heavy hydrogen, on this planet, and we could generate all the power we need from that, and it's not radioactive, except for the fact that it's so hot that whatever power plant we build, it melts it. And if it were but for that one thing, we just find some material that would withstand 100 million degrees, we'd have all the power we ever need. Literally, for thousands of years, we could generate all the power the world needs very safely and very economically if we could just figure out how to hold it. Scientists are trying to build a bottle out of a magnetic field to be able to hold it in a magnet so it wouldn't touch anything. And they've got it to work for a little while, not quite enough to get more power out than it took to start it. But who's to say where this energy can come from? Now we have people, like we heard about a week ago and 2 weeks ago, where they're getting energy from differential temperatures. Differential temperatures, like warmer on the earth, cooler in the bottom of the sea. Those are pretty exciting technologies and concepts. One of the nice things about energy today is we're learning not to need so much. With LED lighting, we use a lot less power. Everything is becoming more efficient. Our computers take so much less power. And if we can eliminate the need for so much power, that really helps. There's a technology that's very popular in cooling homes. It's called an air conditioner. And it's interesting, you can run an air conditioner backwards in the winter, and if you've got one that goes heating and cooling, depending on the season, we call it a heat pump. Interesting thing is it is amazingly efficient. If you put an electric heater in your home to keep warm in the winter, it's 100% efficient. All the electricity you put into the heater goes into heating your air. 100% sounds really good, doesn't it? But if you put it on a compressor and circulate Freon through some coils, you can actually grab heat from where it's cold outside and transfer that heat into your house, and you can get it like 300 or 400 or 500% efficient. Pretty amazing. So learning how to do it right and not need the energy is a great way to eliminate our need. On the other hand, we need better and safer and more stable ways to generate power. And I think we really need to look at that. I remember as a student being told in my engineering class that the world is in real danger of running out of natural gas. And I've shared that with you before. They told us there's only a 6-year supply of natural gas left in the world. Now we'll find some more, but we'll never find enough. And now today we've got natural gas in abundance. And it's really amazing that we've been able to find that, and it's developed. Finding energy sources, finding ways to produce energy without hurting our environment, finding a way to utilize energy more efficient. Those are all things that will really benefit mankind. And if we get enough energy, then I can run my jack invention and capture. And then
It might be harder than you think, actually.
you know, to capture,
To capture me.
well, we need to quit because we're over time. You realize we're borrowing from the next program. But I want to end tonight saying just a minute about ESP. I put up a little post on my on the Acellus blog, the Acellus Facebook site, that I want to make Dr. Angel's ESP courses available to more students. And I've actually been busy this past week putting together a thing on my rogerbillings.com site so that people will be able to look at some of those lectures. What I'm trying to do is make it so parents can look at them and see if they think these will be something that would be beneficial for their students. A lot of people getting a little stressed out by things going on in our world and things going on in your lives. Some of the problems, be them bullying, being whatever it may be that's making your life a strenuous situation for you. And I'm hoping in the next day or so I'll get those live. Anyone that's interested in Zoom, by the way, can go to the Acellus Facebook page, and I'll put the link there. It's going to be on the rogerbillings.com site, but I'm not going to make it so you can find it unless you know what it is. You know what I mean? It's a hidden link. So you got to go to Facebook to find it because I don't want to attract the whole world to it. But the idea is I'd like to make these courses really available for our Acellus students and not have it count as one of your 6 courses, because I'm being told by more and more teachers and parents that they're really making a difference. Now, the ESP course, which stands for Emotional, Social, and Physical course, for last year is out, and a lot of people are doing that already. The courses I'm putting up are ESP2 courses. These aren't even released yet to the students, but I'd like to have the parents take a look at them and see what they think, because I personally think this is an area where we can do a lot to help a lot of people. There are times in our lives that are discouraging. There are times when we just feel like we want to give up, but don't. It's amazing how, even though it looks like there's just no hope, it's amazing how things can work out. And most of the great moments in my life have come right after there was no hope and I was ready to give up. You need to persevere. You need to not give up. You need to just hang on. And I think these lectures will help us do that. But until they get them, I'd just like to say that I am very grateful to you for the effort you've made in providing these. There is a thing that she's doing right now so that when a student signs in, there will be a little thing over there, that a little button you can click on. It's not there yet, it's still being invented, but it's called Crisis Recovery. Is that right?
Intervention.
Crisis Intervention. See, I almost got that right.
We can change it.
No, I like Crisis Intervention. This little button that you can click on, and your parents can give you some help in finding it, or you can even go find it for yourself. You go click on that, and then it's got a list of a whole bunch of crises that a young person might run into in their life. And then if one of those is what you're going through right now, like maybe you're having a real problem with bullying, you go to the bullying one and you click on it, and then you have some lessons from Dr. Monet on how to deal with that particular problem that you're facing. I know we have quite a few parents that are joining with us on these discussions, and thank you. Really appreciate your support. But especially those of you that are talking to me through these links, but especially on Facebook, I would like to know any specific crisis topics that you'd like us to include in that list. We have about how many now?
About 20.
We have
Actually, 20 plus.
20
but
so far, but these would be circumstances that our kids are running into that we could maybe put together some things to help them see that there's hope beyond every crisis. And I would love to get your input on that because we're just filming them right now. All right, well, everybody, thank you very much for joining with us tonight. If any of you get to try my invention and levitate something with a jack. And by the way, I
Go
didn't
for it.
invent a jack.
What'd you say?
I didn't actually
You
invent
didn't?
him. Someone beat me to it.
Oh,
I think it was probably a guy named Jack.
I think so too.
But I'm looking forward to this year's science fair. In fact, I decided tonight, while Johnny was talking about the science fair, that I'm going to make a special prize this year, the Dr. B Award,
Oh, fun.
that I hope one of you is going to win. So start inventing. Let's make the world better every year. Thank you. Good night.
Well, thank you so much for joining us. We'll see you next week. Have a great night.